For my addition to the NBody and planet files, I allowed for elastic collisions and made gravity adjustable as demonstrated in this file, in the hypnosis.txt one. So first of all, I added just elastic collisions, and I did that using these equations, which I found from Wikipedia, and I just decomposed each one into the x aspect and the y aspect for each of the planets that were colliding, and in that way allows for the 2D collisions to be calculated accurately. So the main issue that came up for when I was implementing this was knowing exactly how close the planets had to be in order to consider them colliding. So to do that, I had to kind of approximate it. I imported Java Images buffered image to get the pixel size of each planet, which we can also find in which we can also find in the images file. For each of these GIFs, they have a different pixel size, and I just took, I think, the width of each one and scaled it using the background images 512 by 512 pixel size, and also including the radius that we add in with each file. And using that, I kind of estimated how big each planet or each image was to check for the collisions. And I added a radius aspect for the Planet Extreme class. However, not everything works super well. I kind of tried to optimize it for the Earth planet, so the Earths collide, but for other files, such as Entropy Universe, the collisions don't work quite as well, especially for the Sun. And again, that's because the pixel size doesn't correspond perfectly to how big each planet is. So some of the planets, such as Jupiter and I think the moon, collide well, but with the sun, it either goes through the sun or collides when it's really far away from the sun. And the only way to fix that, I think, would be by adding the exact pixel size for each one of those, which is very hard to implement without a lot of guess and checking. So it's not perfectly scaled and it's more of an approximation, but the collisions are still there. And the second addition that I made was, as you can see here, it shows the constant for gravity and it starts off with the correct double for g, which is 6.67 times 10 to the negative 11. But I also made this adjustable so it makes the simulation kind of interactive. And I did that by adding a key listener. So if I restart the file, the key listener takes in the keys for up, down, left, and right. And up increases the gravity constant by a little bit, down decreases it by a little bit, and left and right increase it by a lot. So when the gravity constant changes a lot, as you can see, the planets go away very fast. That's because when combined with adding collisions, when gravity increases, the acceleration increases, so velocity also increases by a lot. So once the collisions occur, the planets speed very fast away from the sun. And in order to implement this, here's another example. I just added the gravity constant g, into NBody and made it a public constant rather than a private double. So this could be changed. This also means I had to add g as a parameter for most of the functions. And yeah, it allows for these collisions, and also you can change gravity very differently. So yeah, and so this works better for some of the simulations than for other ones. Some other examples where this may not work as well are the it's a trap.txt, where the pixel size for this object really does not correspond to how big it is, so the collisions kind of just cause things to speed away or just objects to be covered by other objects. And here are some other examples.